Hello again, this is Joseph. Continuing how to understand diagrams, specifically automotive diagrams. They can become very complicated. If you remember in a recent video, we spoke about how to follow a diagram and where's the starting point. First thing is, when you have a diagram in front of you, you look at the components, the symbols. Usually in automotive, you have a battery of 12 volts. Here, you don't have that case, that situation. But you can tell the starting point is always from the top. As I specified before, as we had a similar case, we had a case where it said without, and here it says with. Now, if you notice, it says CCM. Without CCM, with CCM. Now, having knowledge, off my top of my head, I won't know what CCM is. So what do? I observe and I follow the rest of the diagram. If you go over here, it says with CCM. You come to a module. If you notice, it says check control module. So that CCM is an abbreviation for check control module. See, I didn't know what it stood for, but when you follow the symbols or you look at the components, that sometimes gives you a hint what the abbreviations are. Now, one path to go, the green one, is without the check control module. Let's see if that's true. Let's follow that path. If we go here, as we see, we bypass and we come right to the bulbs, the lights, which turn on. So we bypass the CCM. Makes sense, right? With CCM means I expect a path to go through that module. Let's see if that's true. If I go through here and it goes right to pin 10. Where does pin 10 go to? It's one pin of here out of the many pins that's in the check control modules. In other words, we are going through this module. If you notice, it is dotted. That means there's another part of it somewhere else in a schematic. This is one part of it. Now, if you notice something else, there is that's a symbol of a transistor. Have you seen my previous videos? Purpose of a transistor could be two purposes. One is to act as a switch, on or off. Other purpose of a transistor is as an amplifier. Now, I'm trying to figure out a schematic, trying to figure out the path of current. I'm trying to figure out how the light bulbs will light. This brings me to with CCM. So now I figured out what CCM is. Great. What's in here? And why do I have to know what is in here? Well, the answer to that is I'm not really concerned what's in there. However, like I just said before, purpose of a transistor is to be an amplifier. I doubt in this case that we need transistors in here to be amplifiers. There's no need for that. But, like I said, first fold, a transistor acts as switches. That would make sense when I'm trying to analyze a schematic. Why? We need switches to be turned on and off through this module to turn on the lights. Why? Well, you might have daytime running lights. You might have lights on automatic at night. Right? So therefore, this module gets information from the other module, acts upon that. The result is these transistors inside will act as switches, turning on and off the appropriate lights. So therefore, these are the left ones. These are the right ones. Okay? As you see, the trunk light assembly left, trunk light assembly right. Two here, two here. So right away you figured part of the schematic, how to figure it out. So let's say for pin 12 here, for pin 4, to this one, 10, going to 7 over here, 5. And if you notice over here, there's another thing, 2 door. That means if there's 2 doors, this is involved. This part of the schematic is involved. When you have 2 doors, you might have 4 doors. That would be a different schematic. So you see, you look around when analyzing a schematic for things that are indication of something. As you see all over in the shaded area, two door, two door, two door. Two door, two door. Right? And of course, when the current goes through here, remember, current flows, not voltage. Current goes through here, lighting this one. Current goes through here. This is a common path right now, and it has to go to ground. Sure enough, it goes to ground. Ground distribution. This is the ground. Okay? So here I use knowledge, how to understand how to read automotive schematics without knowing, again, what CCM stands for, and without even knowing what's in here. By the fact that it said a transistor here, tells me there are switches here. Do I care what really is in here? No, because when you work with something, you're going to change the whole module. So it doesn't matter to me what the transistors are in here, but just to understand how to analyze it, I would figure these are not amplifiers, but these are switches. Of course, I'm going to change again the whole module, not the individual components in it. Therefore, we started at the top. We came back to a certain point. This was the starting point. We figured out this way is bypassing this module. And sure enough, it came true without CCM. This way, we went right through the CCM. Okay? So that's part of understanding diagrams. Let's go to something a little more sophisticated. And please subscribe to my channel on Automotive Electronic Schematics by Joseph. You'll see many, many schematics, how to understand and interpret automotive schematics, and the most sophisticated, and they can get very, very complicated at times, believe me. And my other channel, please go to see transistor amplifiers and other things. Now we come to another one that I picked out, and this is a little more tricky. Again, relays. I made a video about relays, but first, let's understand the concept of it before we start following the current path. We have to understand how the components work, first of all. We know when you get current through a coil, a relay, it gets magnetized. There's an armature involved, pulls in the armature, and that closes a circuit. That's called a controlled circuit. That's called the control circuit. The control circuit. So current has to pass through this relay. As you see the dotted line over here means at rest. When no current is flowing through this one over here without the orange is in this position, at the rest position. And this is what people get complicated about when I get emails. How do I know which position the switch is in? Well, while it's at rest position, meaning it's not being activated, it is in this position, which is drawn. When it's the dotted line, meaning that current is flowing, it gets magnetized, a magnetic field, pulls in the armature, a switch is now in, the contacts actually move to this position, to the orange that I have. That's the fundamentals of a relay. So first you always look for the coil part of it. Then you go for the switch part of it. Again, current has to flow through this. Again, we see the same sequence. A dotted line. This is at rest. This means there's no current flowing. There's no activation, no magnetic field. This will be in that position. When the coil is activated, this is pulled in. So now this one will go to this one. So, as you can see, it's the same circuit almost as before. However, let's try to analyze an automotive circuit. Like I said, this will get quite complicated. We know how relay works. We just explained that, right? We know this is a symbol for a motor. In this case, auxiliary fan motor. We know one side of the motor goes to ground. The other side of the motor has to have 12 volts to it, or B plus to it, to activate it. We know this is a resistor. Now, let's put 2 and 2 together. When you're in a car and you're idling and it's hot, the coolant temperature sensor tells the PCM or the computer how hot the engine is getting. At a certain point, the fan goes on, especially idle where no air is being drawn in. So the fan has to go on. But the fan will go on at a high speed. When you're driving, you have air being drawn in, cooling the engine. And you can see my other channel, like I said, Automotive, Electronic Schematics, and you'll see what I'm talking about. So fine. In order to activate the motor, two things have to happen. What speed is determined by the resistor in it. When you have a resistor, you have a voltage drop across here. That means less voltage will go here. Less current will go here too, to the motor. Therefore, the motor will decrease its speed. When you do not have a resistor, as you see over here, it will be at full speed or high speed. So, let's establish a couple of facts here to really analyze this circuit. Now, let's say I'm a beginner in automotive. I don't know too much about motors. I don't know too much about relays. I know how a relay works. Again, this is the key. Pressure switch, temperature switch. According to the temperature, all of this will be determined. Which one will be activated? Which relay will be activated? If I'm idling, let's say you're waiting for a red light, and that's called idling. Well, of course, on a hot summer day, engine gets hot. Okay? The fans have to go on at high speed. What determines that? The computer looks at the coolant temperature again, sees the temperature on your gauge, you have a temperature. Sometimes it goes to 190, the midpoint 200, right? You turn the air conditioner on, the compressor is on. That's more of a load on the engine. You need more cooling. Now, so by theory, we need a high-speed relay to activate the motor, the fan motor, at full speed. How will this happen? Now let's see. This is the temperature switch. Current will flow, follow the green. Current will flow here, 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 to this. This is being activated. A magnetic field is being created, pulling in this switch to this one. Okay? When this is being in this position, the orange, look at the current. The current goes in here. Now we come to the difficult part. Right? Where is this switch in? Which position is this switch in? Right? If this position, in this position, there is no connection. Therefore, if this is in this position, current is flowing here, flowing here, flowing here, current cannot flow. Right? So therefore, if it's high speed, this current, this relay, will not be activated. Why do I say that? Let's analyze the circuit. Because in high speed, we just said we need no resistor going to the fan motor. That means no current flowing here. Only current flowing is at the rest position from here to here. This contact, the switch, is not being drawn in, so it's in the rest position going this way. Therefore, at high speed, this is not being activated, this is not being pulled in. Therefore, what happens? The current flows here, 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 and you get full voltage across the fan motor, giving it high speed. How does it know? Right here, temperature switch. Talking to the computer, talking to this, activating this. So therefore, one more time, this is not activated. If it's not activated, the switch is in this position. When the switch is in this position, I have no voltage drop resistor, no current limiting resistor. The full voltage of 12 volts will go to the fan motor, giving it high speed. Now let's say you're driving. You're off idle and you're driving. More air is being pulled in to the engine. What would happen to the speed of the fan? We don't need it at full speed. We need it less speed. In this case, normal speed. So what's going to happen now? Now I expect this one to be turned on. And let's see if that's true. Current will flow here, to this. Again, what happens? This is being drawn in. Follow the orange. Okay, fine. The orange, current flows through here, through here. Now, remember we said before, open path. What will close the path? This one. So that means current will flow here, here. This is probably a ground or a switch leading it to ground this relay. In other words, this will either ground this one to work or it will ground this one to work. When it grounds this one, right? Guess what happens? Now the switch is being pulled in. When the switch is being pulled in, boom. Now current can flow through this fan with lower speed. Why lower speed? Because now the resistor is in series with the B+ supply. That's a beautiful circuit. It really is. So see if it makes sense. Pause the video. Go over it again. Again, we need this one to be activated, right? We need this one to be activated. When both are activated by this temperature switch from the computer telling it, hey, the temperature went down. We don't need it that high, the fan speed. It knows current flows here. Activating this one in the orange position. Current can flow here. Now we come to a stop point. What do we do now? Well, we need this one. This one will be grounded. When this is grounded, boom, now you have the complete circuit going through this. Beautiful, ain't it? Let's look through another similar one. Again, we're looking for how to analyze an automotive circuit. If you look at it, it's almost the same circuit as the one before. Before, if you remember, I told you a temperature switch. What's in it? Switches. Where do the switches go to ground? Why do I need that? To activate the coil. The other side of the relay has to go to a ground. Again, high speed relay, I expect not to have a resistor when it's in high speed. When it's in normal speed, I expect to have a resistor to limit the speed of the fan. So let's go this way. Current flows, the starting point is from this one here. Now, the question you have is which one will be, which position will the switch be in, right? So, if we need the high speed one, guess what? This one has to be closed. Let's see if that makes sense. If this is activated, current flows here. This is now ground, right? The other side is connected to ground. That means what? This will go this way. Close the circuit, follow the green, go through here, come out here, and boom, right to the fan. With no resistor, that's full speed. So for full speed, I need this one closed. Now, for normal speed, right? We know for normal speed, somehow this has to be engaged, right? Therefore, the first place you would start would say, okay, let me start over here. Current will flow here, where is the switch? I'm trying to learn how to follow automotive schematics. Where is the switch? I need a ground path. Is the switch here? No, the switch is here. It's open. What does that mean? That means this is not activated. I cannot have current flow. If I don't have current flow, which position is this in? The rest position, this one. Let's see if this is true. Current flows here, right? This position. cannot go through here. In this position, go back here. Now I come again. I'm stuck. What do I do now? What do we say? We need current flowing here, here, here. Now, in order for this to be activated, I need this switch to be in this position, the temperature switch, this position. When that happens, current flows through here through a complete path. What happens next? This is being pulled in. Now it's in this position. Therefore, the current flows through this one that is not activated, through here, through this one that is being activated, through a resistor dropping the speed. Beautiful circuit. It's a beautiful circuit. You always start from the primary or this coil. Follow the path. And two things, always keep in mind when look for main components. When you look how to any circuit, doesn't matter what kind of schematic it is, you look for main components. Main components are fans, motors, relays, B+, fuses. Those are main ones. The resistor is not that main, but it does give me a hint which way the current will be flowing when I need high speed or low speed or normal speed. So once again, this is in a rest position. Current flows through here. Current cannot flow here, but we need a complete path, we said, right? Well, this will help us. Current then will flow here. Current will flow here, through this, through the resistor, giving us normal speed. Beautiful circuit. So thanks for watching, and please see my other videos about scopes, guide how to use scopes, and subscribe to my other channel. I need minutes. Actually, thanks for the subscribers. And subscribe to Automotive Electronic Schematics by Joseph and Joe Electronics, which was many transistor circuits. Thank you for watching.